All right, so today what we're going to do is we're going to look at section 4D, comparing fractions. Now, so what we're going to be doing is we're going to be trying to decide which fraction is larger. Okay, comparing fractions. So what we're going to do is we're just going to compare two fractions. Now, sometimes that's really easy. If you have 1/3 and you have 2/3, it's obvious that having 2/3 of a pie is better than having only 1/3 of it, right? So what you compare is the number of parts you have. But it gets a little more difficult when you have something like 1/3 and, say, for example, 5/6. Because you have to think about how big the parts are. So what's better, 1/3 or 5/6? Yeah, see, it's not quite as simple to just guess. So what we're going to do is we're going to look at a process that will allow us to always compare fractions. And another thing that we're going to be doing here is we're going to be practicing this is going to get us ready to add and subtract fractions, which is everybody's favorite mathematical thing to do. Well, it is going to be now because you're going to see it's so easy if you'll learn it. All right, here we go. To compare fractions, with different denominators. So we're going to compare fractions that have different denominators. Because you can't just look at the top number and say, oh, that has more parts. Because the parts may be so small that it doesn't matter. 1 of something might be bigger than 2,000 of something else. So what we have to do is we have to compare them by making the parts the same size. Okay? Which part of a fraction tells you how many parts things are divided into? The denominator, right? Okay? The denominator names the kind of parts you have. Okay? So that's what we need to do. The first thing is you must have the same, and another word for same is common, denominator. You must have the same or a common denominator. And that's really what this lesson is all about. It's all about common denominators, which is one of the things that most students never seem to put in the effort to learn. But it's really very easy. Now, there are lots of different ways of doing this. I'm going to show you a traditional way, and then I'm going to show you a quick way and I don't care which way you use, but I generally use the quick way because I like it. But it doesn't make any difference. Whichever way that makes you understand it is the one you should use, right? Should you always change to the way I do things? Absolutely not. If you know a way to do it and it works every time, then that's the method you should use. However, if your method only works some of the time, then I would consider changing your method. Okay? Now, also remember that year 7 is not where my teaching, how I've taught for over 20 years where? At a university, right? So I know where you're going with your math, right? So you can learn some tricks that will not work later. Well, I'm never going to teach you those. But I can teach you some tricks that will work forever. Which would you rather learn? A trick that I can use now, but then I have to unlearn later? Or a trick that I can learn now, or a method I can learn now that works forever? You think? Yeah. So, okay? So I'm going to show you some things that will always work. All right, here we go. To find a common denominator. Okay? So, you must have the same denominator. An LCD which is exactly the same as an LCM, least common multiple. So least common denominator is exactly the same thing as a least common denominator. So denominator, the only difference is that now it's in the bottom of a fraction where before it was just a number. Right? And we looked at how to find the LCM of the numbers by simply using that upside down division symbol and then multiplying those things, right? Or factor tree, if that's what you like, that's what you should use. Whatever process that you like, that's what you should do. And some numbers are so easy and so quick that you can just find them. All right? So what I'd like you to do is turn to your notes, because y'all are going to tell me what to do. Turn to your notes and find your notes on finding an LCM for me, please.
I always save that place.
To find an LCM, what's the first thing I want to do? And to write the numbers in a what? Upside down division symbol. Yeah, there you go. Remember this? Okay. Good deal. So actually there's some things that I should look at before that. Sorry guys. So let's look at that. Okay. So first, if the the smaller denominator will divide evenly into the larger denominator, then use the larger as your LCD. Okay, so I'll give you a moment. Now, so that's kind of a special case. So remember that, keep this in mind. The LCM or LCD is always based on the larger number, even though it says least. It's got to be at least as big as the larger one. Okay.
So if you can simplify it.
Next step. You should do that anyway if it'll simplify. You should always start there. Okay. All right, next step. If not, right, then use upside down division to find the LCD. So first, divide out anything that's common to all the numbers. So you could be comparing three numbers, right? You could be finding the LCD for three numbers. But it has to be common to all of them first, right? Okay? Okay. Then, continue to divide as long as something is common to two numbers. Again, these are in your notes, so if you don't get all of this written down now, don't worry about it. I'm going pretty quickly here because we need to talk about how to use it. Okay? Right? And then finally, once you continue to do that, then you're going to multiply every factor on the side and bottom. Remember, the multiple uses everything, not just the things that are on the side, but every factor. Multiply them all. All right. Now, once you have your LCD, okay, then there's another case, remember, though. There's a case C. If they have nothing in common, so no common factors, let's write it that way because that's better. Use the right language. If they have no common factors, anybody remember what I need to do to them?
Keep the same.
Well, not simply There you go, there you go. Simply multiply them together. And that happens more frequently than you'd think. So if they have no common factors, then to get the LCD, you just multiply the 2 or 3 numbers together, whatever you have. Right? But it's all based on multiply. Multiply everything, right? Okay. Now, once you've found the LCD, okay, then think about this, though. If I change the number of parts we're dividing it into, so let's say we have a pie, and I cut it into 2 parts. If I cut it into more parts, I'm going to have more of them, aren't I?
Yes.
So in other words, if the denominator changes, what else is going to have to change?
The numerator.
The numerator.
Yeah.
Right? Because if I cut it into smaller pieces, I'm going to have more pieces.
Yeah.
So, for example, let's say that I have a pie and I cut it in half, then that's just enough for us two. Sorry about the rest of you, right? Okay. But I could cut it into more pieces, and if I cut it into more pieces, I could feed what?
More of us.
More of you, right?
What about me?
Okay? Right? So,
Me and Sarah share the pie.
that is critical, guys. Shh. If you change the denominator, you must also change the numerator. So I'm going to show you a pattern. And this pattern can be used for so many things involving fractions. It's such a good pattern to know. Okay? Now, and the beauty of it is it looks a lot like the order of operations. BEDMAS, what do the D and M stand for? Division, the D and M. Division and... So you already know part of it. Look at this. There's a pattern. And the pattern is called divide, then multiply. Which looks, again, a lot like the order of operations with the DM stuff. Divide, and then what comes next? Multiply. So divide, then multiply. Now, again, if you already use another pattern, and I'll show you the way it's traditionally done, then you don't have to learn this. But if you learn this, it can make something that takes a long time, something to work very quickly. All right? I can show you very quickly. But it is new. And some of you don't like new.
I don't like me.
But we'll see. Okay. Here's what we're going to do. First, write down a new fraction with your new denominator. Now, you'd have to do this anyway, right? Because you're getting a new denominator, that means you're getting a new fraction. Okay? Thank you, James. All right? B. Then, remember, we're going to have, if we get a new denominator, we must also change the numerator. So what we're going to do is simply divide the LCD by the original denominator. Multiply that quotient. What's a quotient? The answer when you divide. That quotient times... Oops. The original numerator. Divide, then multiply. Right? Okay? That product, which is the answer you get when you multiply, is your new numerator. Of course. All right, so what we're going to do is we're going to do one example together just so you can see it doesn't make any difference. So let's say we have 2/3 and we're comparing it to 7/18. Who cares? Can I compare thirds and 18ths? No, the denominators need to be the same. So let's get a common denominator first. Well, for 3 and 18, that's one of the special cases, isn't it? Won't 3 divide evenly into 18? Well, then that means the common denominator is what?
3 times 18.
Is 8. No, not 3 times 18, just 18. Now, that's a common factor. Got to make sure you know which one you're looking at. Okay? Now, if you forget, just go over here to the side and do it like this, and it's fine. Right? That process of doing the upside down division will always work. So if you think that the special cases are going to mess with you, then don't use the special cases. Use the one method that works always, right? Yeah? If you know how to get you from school to home, you don't take a shortcut that you don't know how to use, right? You just go the way you know, right? Now, if I've changed the denominator, what else must I change? The numerator. And I'm going to do that with that divide, then what?
Multiply.
Multiply pattern. So what is my LCD? 18. Divided by my original denominator, which was what? 3, which gives me a 6. And I'm going to take that 6 times what?
2.
Which gives me what?
12.
And that's all there is to it. So it's LCD divided by your original denominator, and you multiply that times your original numerator. So let's do the second one. Now the second one's not going to change any because look, it's 18 divided by what? 18 is the denominator. 18 divided by 18 is a what? And 1 times 7 is 7. We knew that one wasn't going to change. Why? Why didn't the numerator change in that one? If the denominator doesn't change, then the numerator isn't either. Okay? LCD divided by the original denominator, and take that product, put it in brackets. Why? It means do it when? First, and then multiply whatever's left times your numerator. Now, normally what would happen is you would say, okay, we've got to change that into something at 18. What would you multiply 3 by to get an 18? And so 6 times 2 is 12. It's the same process, but if you'll learn it as divide then multiply, you can use it with bigger numbers and you won't have to do so much in your head. Okay? All right. Now, so which fraction is bigger? 12/18 or 7/18? Yeah, this one's bigger. Right? Would you have naturally thought that 2/3 was bigger than 7/18? Some of you would, some of you don't. Some of you can see things a little spatial reasoning a little more clearly. That's fine. But the only way to be positive is to practice. All right. So there are your notes. Study them before we meet tomorrow to do more of these examples.